Please do. Well, it's just a matter of still that becomes plus 9. So that doesn't change. It's still negative time for that plus 4. Down here, it's minus 5. That's like negative plus. Minus. Minus the negative. This carrot. Where's that for? Alan? Look at the carrots. That's supposed to be 4, a negative 1 constant. And then over here.
Yeah, I'm sorry.
Oh, well, that's why it's a quiz, and that's why, you know, better to make it here than on test. Leticia? So I don't know where you do have a parallel line, but when you plot that point, it's -4 down 3, so it's here, and it's horizontal. When it's horizontal, y equals by itself, and then y equals to Sarah? Sarah? Am I saying it right? Side right. Yeah. Positive 5%. It's negative 5%. But what's the flow to the line? So it's horizontal, y equals to constant. This y is always Julia Hernandez. Afterwards. There's y minus that one. It's a negative 5. Minus the negative. Left off. So the negative 5%, that would be 4. 4. It's both that much stuff. Yeah. This is right. So that okay. I don't know why we do this. To the perpendicular to the y-axis, this would be the only. So this one is not part of it. I just don't want you to get confused. You have two of them. This would have been the vertical, but if they would, if I would have said parallel to y, then it would have been up picture. If I would have said perpendicular to the x, then it would be. This is parallel to y, this is perpendicular to x. This is parallel to x and perpendicular to the y. So it's, yeah, so the little right angle would have been there, perpendicular. This is your y. So that's why it's horizontal, and you wrote it out right. So. Oriana? But when you, I did take off points now, and I'll mention this to the whole class. When you do a single number, you don't need parentheses. It's just like labeling the number line, just put a 6. When you have an ordered pair, you have to have a parentheses. Down 7 over 4. This point is x is 4, y is -4. So it should be this like this. Okay. And here, when you plug in the point, x is 15, y is -5. So we get, yeah, you got that right. You got working. So this is 6. So -5 equals, that's just 6 plus b. We're going to subtract 6 from these sides. So -5 minus 6 is -11. You added 6. At the bottom of the 6 there, so you have to subtract. Yeah, so what you probably needed to do was one more step. You have 6 over 1, and then you don't show that you're doing it to both sides. So you have -5 equals 6 plus b. So then show that I'm going to now take 6 away from both sides to undo that positive 6. So now you can see it has to be a -6 from both sides. Okay. And then else. Okay. Well, here's what we got this perfect. Everything's looking good right now. So you've got what? Subtract 7x minus 7x both sides, which should be negative. And then you divided everybody by 4. But then where'd the -7 go? So you have -7 over 4, and then plus 6. So it would have been y equals -7 over 4, x plus 6. So the slope would be -7 over 4. And your y-intercept is 6, that's right. But you would have gone down 7 and over 4, and that would have been there. So for some reason, the 7 just disappeared. So you want to, as you write these things down, from left to right, and bring it down top to bottom. Don't leave anybody behind. And then right here, y2 minus y1. There's no -1. If you plug in -1, it's -9. So that's just, be careful. Other than that, you're doing the process right. Okay. Glennis? Kyle? This point, -4, -3. I don't know why you put this point. So it's perpendicular. So it goes this way with the y-axis. So it's going to be a horizontal line. So you put y equals -4. First of all, the -4 is an x coordinate. Y couldn't. So you draw horizontal. Diego. Tony. Lena. Juliana Martinez. Did you mention about the due date? So you just got to change it. I had never changed it to the day of the test. So the slope is negative. That's seven. And then for some reason, it's positive 4y. You divided everybody by -4. It's positive 4, so everybody gets divided by positive. So it'll be -7 over positive 4. So the y-intercept positive 6. And the slope is down 7 4. Well, no, because you just need to get one line. If you divide by -4, then positive 4 divided by -4 is going to be a -1y. We don't want -1, we want positive. So if it's multiplied by 4, we divide by 4. If it's being multiplied by -4, then you will divide by -4. Okay. Stop. It's fine. So the slope is 2 this, and that just messed everything else up. But that's why it looks here. The picture is perpendicular. This is your y-axis, so it's perpendicular to the y. So that, okay. And when you wrote the vertical, then you drew vertical. But you wrote x equals -3. Or x to the power equals that. So that's the other part. Okay. So Delia, Tony, and Diego. All right. So, little fast forward here. Not too fast. This is the review sheet. Not a review sheet. Where the review sheet? Oh, nice. So this is the review sheet. Yeah, this is the one I'm going to give you this today. We get the review sheet printed today. And again, the review sheet is not mandatory. But this is what I'm going to let you ask questions about on Tuesday next week. That's just Thursday. The first 4, and I'll go over how many of each kind you're going to have on your test. Again, no surprises. But the first 4 questions, slope. The next 4 questions, write the equation in slope-intercept form, y equals mx plus b, of the line described, if possible. If it's not possible, use the appropriate special case notation. Number 5 is just like the 2 warm-ups here. Write the line that is perpendicular to y equals -5 over 2x plus 2 that goes to the point -5 3. This is just like the quiz question. This is just like the bonus question on the quiz question. And this is, hey, step 1, find the slope. I found it. Is it a special case? No, it's not 0. It's not undefined. So find the equation of line. If you have the slope and you have a point, and again, I don't use point slope form. I just go straight to slope intercept form, which is supposed to end up with anyway.
But it's a quicker problem than that one is, because in this one, you have to find the slope yourself. This one, you're given the slope to start with. But 5, the equation of the line that's perpendicular to this line. Not perpendicular to the x or the y-axis, not parallel to the x or the y-axis, which are special cases, but perpendicular to another line. Now, again, with the little foreshadowing, this is what your test looks like. So directions on the test, you're going to see this is what it looks like. The first 3 questions, let me put them next to each other so I can just easily click back and forth. I said right next to each other. There we go. So on the review sheet, first 4 questions, slope. On your test, the first 3 questions I'm going to instead right next to each other. There we go. The first 3 questions on your test, find the slope. Okay. The next on the review sheet, 4 questions, write the equation of line, slope, intercept form. On your test, the next 4 questions, write the equation of line, slope, intercept form. This problem right here, number 4, is going to be just like this question right here, number 5. Now, here's what makes it nicer than the one you just did as a warm-up. Step 1 for writing the equation of the line is you have to find the slope. Right here on the review sheet is exactly how it's going to be for your test. I'm going to give you the line that you're comparing it to in slope intercept form. So you have the slope just staring right back at you. The warm-up that you're doing, not you, not you, oh, I know. Not you, this one. Parallel and perpendicular, you have to figure the slope out because it's written in standard form. So I'm not going to do that to you on this test. That'll be for chapter 8 and 9. Okay. For this test, you got to find the slope. I'm going to make it very blatant, very in your face. Here you go. Trying to hand it to you. You're going to see an example of it on the review sheet. You're going to be able to transcribe that basically. Again, no notes, but you're going to have to practice for it. On Tuesday, we're going to do a warm-up with more practice just to make sure we get it. So let's do this warm-up. When I first encountered this question, this says, write the equation of the line, slope intercept form, y equals mx plus b, through the point 16, negative 16, positive 9, parallel to the line. So here's what I've been trained to do so far. Hey, I see parallel, perpendicular. I'm thinking special case. But it's only a special case if it's parallel or perpendicular to a horizontal or a vertical to start with. When it was parallel or perpendicular to the x-axis or the y-axis. This is not a special case. It's not parallel. This is not x by itself. This is not y by itself. This is not the x-axis. This is not the y-axis. This is just another line. So, parallel lines, the slopes are equal. Parallel lines don't intersect. Remember what I told you? The 2 L's in the word parallel, sideways look like an equal sign. Slopes are equal. Is that? Wow. So the slope for my line is going to be the same slope as this line. So step one, you got to find the slope. I take the slope of this line. So how do I get the slope of this line? I need to solve for this one's y. Y equals mx plus b. Subtract 4x from both sides. So that positive 6y equals, in order, negative 4x and then a positive 7. And then we divide everybody by 6. We divide by positive 6. And so we get y equals, always simplify. It's going to make your life easy. Always reduce when you can. A negative over a positive is a negative. 4 over 6. This is 2 times 2. This is 2 times 3. The 2's reduced. 4 over 6 is 2/3. Negative 2/3. X plus 7 over 6. That's the equation of the line that I'm supposed to be parallel to. What do I need? I need its slope. What is the slope of this line? Negative 2/3. My line is parallel to that line, so my slope is equal to that slope. So my slope that I need over here is negative 2/3. Step one, I gotta find the slope. The slope that I need is equal to that slope. So I find that that one is negative 2/3. That's what I need over here. Now, here's the most important piece. I am through with this equation. I don't need it for anything else. Because now I'm supposed to write the equation of a line through this point parallel to this line. So I was supposed to find the slope, which I did. Now I'm going to write my own equation. I needed the slope. I got it through negative 16/9. So this is the telltale woe of my life. This is just like that girl in my sophomore year who needed a date to Christmas for me. So she started being nice to me, right around the late November. So I said, wow, somebody's actually talking to me. So I'm all in. She just wanted to go to formal. As soon as formal was over, I never saw her again. Had me take her to formal, never needed me for anything else. We're done with that, just like she was done with me. Okay? We don't need this line for anything else anymore. We just needed its slope. She just needed a date for the formal. Okay? You hear that? She's like, nope, no, she won't. I'm sure she has a better one. Therapy. You guys are my therapist. Okay, so now I got the slope. Here we go. Now, again, I told you on your test and quizzes, I will give you nice numbers. Right here, this one's not so nice. This one's going to end up with fractions, but it's a good example. Just bear with me. It's not going to work out nice when you start it, but I'll show you how we can make it work out in the long run. When you take the test, I make sure the problems work out nicely. If you end up with fractions in there, you did something wrong, come on up and ask, and I'll tell you what I won't tell you what you need to fix. I'll try to focus you in a different direction so you can fix it. Here we go. Non-special case. So we set up y equals mx plus b. All right, I got my slope, plug it in. Negative 2/3. X, I just need to figure out b. To figure out b, we plug in an x and a y. Just like you did on the quiz, yeah.
What happened to 8 over 7? No, 7 over 8.
There's no 7 over, 7 over, okay. So this is the equation line. Okay. All I need from this line is the slope. That's all I need. I'm not graphing it. I don't need it for anything else. She just needed a vapor formula. That's all she needed. All we need from this is the slope of the line. So we don't need the y-intercept. We don't need this at all. We just needed the slope. Okay. Okay, good. Good question. So now the slope of b, you have to plug something in for the x and the y. So you need to, on the quiz, you had 2 points to choose from. What's nice is you only have 1 point to choose from. So it's real simple. You're going to pick this x and y. We're going to let x equal -16 and y is equal to 9. Plug them in. Over here, 9 equals -2/3 times, don't forget the sign, a -16, and then plus b. Okay. So 9 equals. Now, this is what I promised would happen for you guys on your test and quiz. This is a warm-up. This is an example. And it's a good example for what to do if something doesn't happen, like in a different class or some other jerk of the teacher. Negative times a negative is going to be a positive. What I told you, you will always get from me on tests and quizzes. This should reduce nicely so you don't end up with a fraction here. 3 should go into this or somehow reduce. Well, 3 does not go into 16 either. It doesn't reduce. So this time, we do have a fraction. A negative times a negative is positive. 2/3 times -16 is positive 32/3 plus b. All right. Corrections. No decimals. No decimals. Can't change that to a decimal. Gotta work with fractions. So to solve for b, you could subtract 32/3 from both sides. So then you got to get common denominators and you do the subtraction. Do yourself a huge favor. Leave it with improper fractions. I know you've been told as you were growing up all through math classes, you're supposed to write it using mixed numbers. 32/3 is 10 2/3. 3 goes into 32 evenly 10 times, and you have a remainder of 2, so that's 10 2/3. Listen, when we do mathematics, if you're going to add, subtract, or multiply fractions, you're going to have to convert it to an improper fraction anyway. So just leave it improper. Just make sure it's lowest term. Make sure it's simplified. Now, in the real world, nobody's going to go, next door and say, "Can I borrow 32/3 cups of sugar?" Or I ran 32/3 of a mile. I ran 10 2/3 of a mile. Or it's 10 2/3 of a mile to the next, gas station. We don't speak with improper fractions, but when you do the math, you have to do the math with the improper fractions. But back to the equation. You'll see on the warm-up on Tuesday, I'm going to give you an example of the bonus question. The example of the bonus question that I give every semester is an Algebra 1 question. solve an equation that has fractions. So this is it's a real simple equation and it's got a fraction. So you can work with fractions, or because it's an equation, you can undo the fractions. This is what I'm talking about. When you have fractions and it's an equation, if you multiply every term by the least common denominator, you undo the fractions. And now you have a nice, simpler question to solve. So let's look. This is 9 over a 1, 32 over 3, and that's a b over a 1. The biggest problem about this question, what causes the fraction, is that denominator 3. It's the denominator's fault that we have a fraction. The common denominator for all three of those terms is a 3. What will undo division? Multiplication. Because that's what a fraction is. It's a division problem, 32 divided by 3. So if I want to undo right now this divide by 3, I would multiply this guy by 3. But that's the problem. If you only multiply one thing by a 3, you've changed the equation. It's not the same thing. Here's the deal. If you multiply 1, you multiply everybody. It's back to the Oprah show. If one person gets a car, everybody has to have a car. If I multiply one term by 3, everybody has to get multiplied by 3. Multiply every term by the least common denominator. To undo fractions in an equation, multiply every term by the least common denominator, LCD. So I get 27 equals 3, and then what is 3 over 1 times 32? The 3 is reduced. That's the reason why we're multiplying by 3 in the first place, is to undo that fraction. If you look at it, 3 times 32 would be 96. 96 divided by 3 is just 32. And then plus 3b. You now have no more fractions. No more fractions. So to solve for b, you now just subtract 32 from both sides. 27 minus 32 is negative 5, equal to 3 times b. And then you divide both sides by 3. And b is equal to negative 5 over 3. So the missing y-intercept, b, is negative 5 over 3. So the equation of the line that's parallel to this line through that point, y equals negative 2/3 x minus 5 over 3. Now, if you start to get a little, little anxiety attack because of all the fractions that we just did in the last 5 minutes, here's the most important piece. Where I start. I'm going to write the equation of a line. We always start with, I need the slope. Where did the slope come from? I found this slope, and I used the same slope because parallel means equal slopes. That's the most important thing. Parallel means equal slopes. Okay. Over there, perpendicular. Perpendicular. So for perpendicular, slopes are opposite and reciprocal. Opposite and reciprocal. So you change the sign and you flip the fraction, or you flip the slope. Remember what I kind of gave you an idea. This is the symbol for perpendicular. So they're opposites. Well, opposites kind of like a horizontal versus a vertical. They go in opposite directions. Okay? Perpendicular lines. Slopes are opposite and so opposite directions, and that perpendicular symbol is like a T that got flipped upside down. A T that got flipped. And when you flip something, that means reciprocal. That's the mathematical. That means you want to flip it. Opposite and reciprocal. Change the sign and flip it. Step one, I need slope. Can't write the equation unless you have slope. So I need the perpendicular slope to that slope. So here we go again. By the way, I never went to another high school day. My wife told me that if she had known me and if we were like, she was the closest I was at San Joe more, but if we had been at the same high school, she never would have gone out. You know, something about she didn't date nice people. I guess it was her bad boy days. I could be a bad boy. So, step one, gotta find the slope. Solve for one. You subtract 18x from both sides. And remember, I just want this slope so I can figure out what my slope is. I have 6y equals, I've got a negative 18x and a plus 1. And then you divide everybody by 6. Sorry about that evil division right there. And it happens every now and then when you divide by pieces. Omen, Damien type. Y is equal to a negative over a positive is a negative. Simplify. 6 goes into 18 how many times? 3. So this is 3 over 1. It's 3x. Simplify. It's 3x. And this is 1/6 plus 1 over 6. That's so what is the slope of this line over here? No x, just the 3, negative. Okay. The slope is just the coefficient of the x, not the x-side. So the slope that I need from that is the opposite. So if that's a negative, my slope's going to be a positive. That's a negative, mine's a positive. And reciprocal. So I have to flip over a negative 3. But what is it going to look like if I flip over a negative 3? 1/3. Remember, this is negative 3 over a 1. If you just have an integer or a whole number and you're trying to flip it, what is it going to be when you flip it? Well, any integer is something over a 1. You can only put a 1 in the denominator. So when you flip it, you get 1 over that number, always. So technically, you can see right here, this right here would have been 3 times 6 over 1 times 6. The 6 is reduced and you're left with -3 over 1. So my perpendicular slope is +1 over 3. That's the slope that I need.
So when we get a -3, we just leave it.
So the positive happens because of the word opposite. Opposite means whatever the sign is, you're going to change it. If this came out to be a negative, my slope is a positive over here. If that's a positive, then my slope over here is going to be a negative. That's where the opposite is. Then the second part is then you flip it. So 2 things you have to do. Change the sign and then flip it over for perpendicular. Okay? Change the sign opposite and reciprocal. For perpendicular, yes. Okay? Parallel, they are equal. Parallel is exactly the same, just like the 2 L's in a parallel. So whatever that slope is, this is the same slope over here. Don't change a thing. Okay? Now, for your test next week, like I told you, it's not going to look like this. It will be this. I'll give you that as your equation instead. So it's already in slope intercept form. So the slope is staring you in the face and you don't have to go through the whole solver. Okay? Just slope and then heads up. So there's my slope. And it's going to go through -9, -15. Step 1, I found the slope. Step 2, not a special case. Step 3, I'm going to write down y equals mx plus b. Step 4, we plug in the slope. So I plug in the 1/3. Y equals 1/3 times x. Just got to figure out the b. To figure out b, choose an x and a y that you can plug in. Well, you only have one x and y to choose from, this one and this one. That's the x and this is the y. So I'm going to let x equal -9 and y is equal to -15. For the y, -15 is equal to 1/3 times x, which is -9, and then solving for b plus b. This is much more like what I promised you guys. It's going to reduce nicely. What's 1/3 of 9? 3. You see how this goes into 9 nicely? It's 1/3 of 9 is just 3. That's what I promise will always happen all semester long when you do stuff like this. So -15, a positive times a negative, get your signs right, is a negative. 3 goes into 9 3 times. So it's 1 times -3. It's -3 plus b. No more fractions. And we just add 3 to both sides. -15 plus 3 is -12 equal to b. So the missing y-intercept that we needed right here is -12. So the equation that we need to write, y equals 1/3 x minus the 12. And that's the equation of the perpendicular line. That's the equation of the line that goes through this point and is perpendicular to 18x plus 6y equals 1. Okay. It is exactly what we've been doing all along. You need slope. So how do we get slope? Well, we have 2 points, that's great. If we're given the slope, that's great. But they're telling us it's parallel to something else, so I use the same slope. If they're telling us it's perpendicular, I use opposite and reciprocal. Okay, so it's on the review sheet, so you can practice. We'll do a warm-up on Tuesday, so again, we can practice. Okay.
So the 3, how do you give them with this 3? If you
A positive times a negative is a negative. 1/3 of 9 is 3.
and what happens to 1?
What's that?
And what happens to 1 the 1 out?
Well, okay, it's 1/3 times -9. So this would be -9 over 1. If we just go straight across, 1 times -9 over 3 times 1. So it's just -9 divided by 3. That's your -3. Or if you reduce it, 3 goes into 3 once, 3 goes into 9 3 times. So now when you multiply straight across, 1 times -3. Well, 1 times -3 is -3. That's what happened to the 1. And then 1 times 1 is 1, and -3 over 1 is just -3. Yeah.
I have a question. For the slope, do we always have to put a 1 in the sense like a -3x? Or like is the slope always going to be a fraction?
If you're doing opposite and reciprocal, if I need the perpendicular slope, you're going to want to flip it. So you're going to want to know what's going to go, flip it over here to see this. Now, if I was just writing the equation of the line, I would not put -3 over 1 because -3 over 1 isn't simplified. -3 over 1 is just -3. For example, let's say that this slope over here, let's just say that the slope over here came out to y equals, and in fact, I'm gonna blank out the board so you don't confuse it with this part right here. So y equals +1/5 x minus 4. And I want a line that's perpendicular to this, perpendicular through 8 -2. So the slope of this line over here is what? It's +1/5. So my perpendicular slope is going to be opposite. It's going to be a negative. That's positive. My perpendicular is going to be a negative. And then the reciprocal. What's the reciprocal of 1/5? So it'd be -5 over 1, but then the directions always say simplify. The directions on every quiz and test are always going to say simplify. So if you leave 5 over 1, yeah, that's not simplified. 5 divided by 1 is just -5. The perpendicular slope would just be -5. When you plug it in, that's what you would use. And that would be a lot easier to just work with just -5 than trying to think about a fraction of 5 over 1. Why would we want to see 5 over 1 or -5 over 1 if we're graphing? If you had to graph, when they clean the boards with like some solution, the next day it just doesn't erase. And this is killing my shoulder. Hey, workman's comp. Not to mention, my wife is an athletic agent. I can get the duck to come over and give me more money. So if you were going to graph y equals 4x minus 3. So you want to know slope and y-intercept. That's how we graph. The slope of this line is 4 and the y-intercept is -3. My gosh. I'm gonna have to like go on Craigslist and find somebody to come in and do it. No kidding. So first thing you do is you plot the y-intercept. And a lot of I remember to talk about it. When you plot the y-intercept, you can label it with just a single number because it's like a number. So right here, down 1, 2, right here, -3. Now there's a couple of you when you labeled that on the y-axis. You labeled it with just a -3. When you label a single number on a number line, just like that, you don't put parentheses around single numbers. You only need parentheses when you put an ordered pair, when you have an X and a Y. So if you were to label this with the ordered pair, 0, -3, then yeah, you would put the parentheses around. But when you use just a single number, like you're allowed to for the axes, don't put parentheses around single numbers. On the quiz, I didn't take any points off of this time because I didn't mention it in a few days before. But now I am. You would lose a point when you do that on your test or quiz from here on out. So -3. My slope, 4. I need rise over run. I need to know what over what. So this is why you would want to rewrite this as 4 over 1. In the equation, you don't put 4 over 1 because if you put 4 over 1, it's not simplified. Okay? You just put 4, I should write in the equation. But when I graph, I want to know what the rise and the run is so I can graph it properly. That's all. That's why I would change it to 4 over 1, up 1, 2, 3, 4 over 1. The coordinates of that point is 1, 1. Then you draw a line. And don't forget those there. Nobody did. Everybody had the arrow. Let's come on back at 44. Get y equals mx plus b and then convert it to standard form. So step 1, we got to find the slope, and we don't have the slope given. We have 2 points. So let's not forget, you have to know how to find slope. Y sub 2 minus y sub 1 over x sub 2 minus x sub. So which y do you want me to start with? The 3 or the -5? So -5, this y, minus 3, that y. If I start with this y, I have to start the denominator with this x, -9, minus built-in negative, minus, and then this x is a parentheses -8. Y sub 2 minus y sub 1, and then subtract the x. -5 minus 3 is -8 over. This is still -9. 2 consecutive negatives makes that a +8. -9 plus 8, -8. -9 plus 8 is -1. Simplified, what's -8 divided by -1? +8. The slope of this line is +8. Not a special case. Then we write y equals mx 15. And now we plug in the slope. Plug in 8. Y equals 8x plus b. Now we just got to figure out the b. So we need to plug something in for x and y. This time we have 2 ordered pairs to choose from. Pick one of them. It doesn't matter which one you choose. You can pick the first set of ordered pairs or the second one. Use the x and y and solve for b. So the first one or the second one, which ordered pair do you want to use? First one. So if I use -8, +3, that means I'm going to let x equal -8, and the y is going to be +3. So going in for y is 3 equal to 8 times. X is -8, so going in there is -8. And then we're solving for b. Now, I don't want to confuse anybody, but I'm also going to, and like the word prove is too harsh a word. I'm just going to demonstrate. If you would have told me to use y equals 8x plus b, and if you would have chosen the other one, if I would have used -9, -5. So let the x equal -9, y equal -5 instead. Going in for y, -5 equals 8 times. X is going in as a -9, and then plus b. I just want to show that no matter which point you pick, you're going to get the same b, because they're both on the same line. That's all. You don't have to just do both of them. I'm just showing that it will have to work. So keep on going here. I get 3 equals 8 times -8 is -64 plus b. To undo -64, we add 64 to both sides. 3 plus 64 is 67. That's the y-intercept, b. If I do it over there, -5 is equal to 8 times -9, so it's going to be -72 plus b. So you add 72 to both sides. -5 plus 72 is equal to +67. It didn't matter which order pair I plugged in for the x and y, I didn't get the same b no matter what. So if you're sitting there and I don't know which one to pick, I don't know what, Does it matter which one I pick? No, it doesn't matter which one you pick, just pick one. Quit staring at it. You know, just close your eyes and pick. You get the same answer no matter what. So the equation of the line, the missing b, is 67. So we get y equals 8x plus 67. But that's not the answer. Then over here, we have our slope-intercept form. Y equals mx plus b. They want standard. Standard form. The x and the y are on the left and your numbers on the right. So I just got to bring this 8x over to the same side as the y. That's how I convert this into its standard form. If that's a positive 8x, how will I bring it over to the left side? Yeah, subtract 8x from both sides. So you have negative 8x. That's a positive y, so plus y. And over there, you're left with a positive 67. So let's see. There's a negative 8x, so it's good. But that's a minus y. That's not good. So that's not that. 1x and 1y, I don't think so. Positive 8x, no, we have a negative 8x. That's not. Negative 8x plus y, and then a positive 67. Okay, so this one is D. And as I pointed out earlier, the reason why I don't do standard form is because that's the correct answer. But technically, it could have been positive 8x minus y equals negative 67. That's exactly the same answer. If you just multiply every term by -1, it becomes this. It's the same equation, just multiplied by a -1 on both sides. So this one works and this one works. If I multiply everything by a 2, I get the same line. It's the same equation. There's an infinite number of ways to write the same answer. That's why they do it with multiple choice. You got to find the right one that matches up to what it's supposed to be. They're not going to let you just type it in. When I ask you to put it in slope-intercept form, and you get y by itself, there's only one way to write it. Everybody would write the same answer if it's going to be right. Makes it a lot easier for you to grade if there's only one answer. Okay. Find the equation of the horizontal line. Step 1, find the slope. It's horizontal. Wait a second, that's a special case. Right on, horizontal, yay. This is the one where it's nice and simple. Horizontal through the line, through the point, 6, 3. Now, it will help sometimes if you draw a picture. And that is if it's parallel or perpendicular to something else, special case wise. This one, you could get away without drawing a picture if you had to. But just to be consistent, horizontal through 6, 3. 6, 3 is in quadrant 1. So we go 6 to the right and then 3 up. So there's 6, 3. Horizontal goes left to right. The horizontal goes like this. So that's the line that it's driving. Horizontal, lowercase h, looks like an upside down Y. Little bit, to use imagination. So for the horizontal line, it's always Y equal to a constant. So what maintains that this is always going to be horizontal is that the ordered pairs all have to have a y coordinate of 3. The y coordinates have to be 3 if it's going to stay horizontal. So the equation of this line is just y equals 3. That's it. That's all you do. If it said it was vertical through that point, it would be x equals 6. If vertical is x by itself. Now it says type the answer in standard form. Well, the rules about standard form, that ax plus by equals c. One of the conditions on standard form, it says A and B cannot both be 0. One of them could be 0, but both of them can. So you could have A equal 0, so all you have left is a y. Or the capital B could be a 0, so all you have left is an x. If capital A is a 0, then it's going to be a horizontal line because all you have left is a y. And if capital B is a 0, then all you have left is an x, so it's a vertical line. So when I write down y equals 3, what I'm really writing down is 0 times x plus y equals 3. That's the standard form that's really happening. But you always simplify. 0 times x is 0. 0 plus what? This is all you write. You don't put the rest of this stuff. Okay. Always simplify. Is there any other questions that I haven't gone over that you might want to see from the homework? Let me take a look through here. I do know towards the end, a lot of these are now repeats. Slope intercept, you have the slope and the point. We kind of pull back out parallel to the x-axis. We've done those earlier. Through the 2 points. You got a slope and a point. This one. All right. So 46. Find the value. This leads in the reason why 46. Wait a second. This doesn't look like what we did. You're right. 46 is a little preview of 3.6, section 3.6. You're given an equation, and they're telling you to plug something in for the x value. Find the value of x squared minus 4x plus 3. Find the value of this expression for x equals 2. You're supposed to let the x equal 2. In other words, substitute 2, plug in 2 for x. What do you get? So we're just going to plug in the 2. So instead of x squared, it's now 2. This is where if you take my advice and try to be a little careful with your substitutions, you'll get more correct answers than incorrect answers. When you plug things in, when you make substitutions, parentheses are going to be your best friend, whether you're plugging in positives or negatives. And I'll show you what I mean if we change this question. It all will build. If I just go 2 and go 2 to the second power minus 4 times, that's going to be times 2, and then plus 3. That's really no big deal. I mean, you could even go just 4x, you can just go 4 times 2. You can do that. Okay. Nothing wrong. So, order of operations is now how you complete the problem. There's no parentheses. The next thing you take care of is exponents. 2 to the second power. 2 to the second is 4. Now, is it okay for me to multiply 4 times 2 at the same time? For this problem, is it going to affect anything if I go right here and go 4 and then minus 4 times 2? That's going to be an 8. Is that okay? Absolutely yes. Here's the reason why. In the order of operations, what's the last things you do? What's the last operations you always do? Add and subtract. The last operations you're going to do is going to be add and subtract from left to right. Because you have a minus here and a plus there, this operation of multiplication is okay to take care of because you still aren't going to do the subtraction. You won't do the subtraction until last anyway. So as you go from left to right, multiplying these two together is not going to affect what you're doing right now. How can you get better at it is you keep practicing. Okay, if you're getting the right answers, you're doing them right. When you're getting the wrong answers, we've got to figure out what mistakes you're making so we can correct them. Because if you can't complete the order of operations, we're at a big roadblock. We're going to do lots of substitutions. And if you can't make the substitution and simplify, that's going to be a little bit of an issue. And then we have a plus 3. So I took care of the exponent and I did the multiplying and dividing from left to right. So now all I have left is 4 minus 8 plus 3. Now I went over this 2 weeks ago. Addition and or subtraction in order from left to right. It is not, I told you this, it is not add, then subtract. There is no then. There's no then. So if you go 8 plus 3 first, you did it wrong. Because that's not 8. It's a negative 8. Got a minus in front of it. So just go from left to right. 4 minus 8 is negative 4 plus 3. And then negative 4 plus 3 is negative 1. If you just on a calculator go 4 minus 8 plus 3, you'll get negative 1. In order from left to right. Okay. That's a huge misconception that students come out of elementary school with. They think they hear the word then, and there is no then. It's just add and or subtract just in order from left to right. It's you deposit $4, you spend $8, you deposit $3, you're now $1 overdrawn. Okay. That's what happens if we plug in positive 2. We get negative 1. Now let me see the next one. Yes. The next question is the same equation, x squared minus 4x plus 3, but this time they want you to plug in negative. So the first one I plugged in, I didn't take real good care of it. So I want to show you now, because they asked you to plug in negative 2, what I hope you always will do is when you plug stuff in, you got to be careful. And the best way to be careful is parentheses, especially on your negatives, especially on your negatives. So over here, I'm going to do it wrong. X squared minus 4x plus 3 if I let x equal -2. This is what I see students do when they get it wrong. They go x squared, so they go -2 squared minus 4, and they go times, and they just put -2 and then plus 3. Which, okay, they wrote it down, but the way that this is written, -2 squared, the way that this is written is -4. That's not what they're asking for. It's not correct. Okay, they want you to square x. They want you to square all of that, the -2. Right here, this is a huge problem. -4 times -2. Well, I'll tell you right now, sometimes they put that multiplication so small, they think it's -4 minus 2. They can't read their own writing. Okay? Habits, make good habits. Even if it was the positive that I did earlier, parentheses when you substitute. Going in for x, parentheses, -2, and then I'm going to square that. -4 times multiplication, -2. And then plus 3. Parentheses will be your best friend. Get it right. Okay. This right here, -2 without a parentheses squared. The reason it's -4 is because when you write this out, it's negative and then 2 times 2. The negative is not being squared. It is not part of the exponent. It's not part of the base. It's just a negative and then 2 times 2, so that's -4. When they want you to substitute -2 in for the x, that means you're squaring everything that x is. So if I plug in -2, I'm going to square the 2 and I need to square the negative. So this has to be -2 times itself, -2 times -2. Which is who? That's a positive. And then I'll get students say, well, couldn't I just go, hey, -2 squared, that's just going to be positive 4, because I know it is. And I'll say, well, what you wrote is not what you have. And I'll put this on the test. And I take off points. I got tired of writing the whole phrase out. Work does not justify the answer. What you have right there is -4, not positive 4. You should have put parentheses. Now, I understand what you did in your head was right, but what you wrote is wrong. And that's my job, is to fix those things. Okay? And then right here, a negative times a negative is a, so that's going to be +8, and then a +3. And 4 plus 8 is 12, 12 plus 3, we get 15. Substitute. Okay. Now, the last bit of questions here is, by looking at the picture, is it yes or no? And this is this leads into 3 6s. What I like about this question is, can you read and translate those words into mathematical language that you can break down and understand? For the graph on the right, determine whether any x values correspond to 2 or more y values. That means, is there an x value that has 2 y values at the same time? So let's just pick -5 right here. Does this x value have 2 different y values simultaneously? Yeah. Up here, oh, you know what? That's not true. -4. Because it's right nicely right there on the graph. When x is -4, the y value is a +2 right there. And down here, this x is -4. This y value down here is -2. So any x values correspond to more than one y value. Yeah, a whole bunch of them do. In fact, every x value to the left of 0 has 2 different y values. Okay. That's a huge connection to 3/6. So, do any x values correspond to 2 or more y's? The answer is yes. And 49, the graph is a circle. Do any x values have more than one y value? What about x is 0 there, and down here, x is also 0? Doesn't 0 have 2 different y values? +5, -5. And then this one, whatever this x is at -2, you got 2 different y's there. When x is -4, you got 2 different y's. When x is +3, you got 2 different y's. Yeah. Okay. That's another yes. Well, if you watch Storage Wars, it's a yep. And then this is just, is it a horizontal or vertical? Y equals 4/7. Horizontal. Y by itself, horizontal. That's good. Oh. And one more time, are there any, this is all the problems that we did in class. As examples. Did a whole bunch. But did anybody run across anything that they have to ask about? This is 1 through 50, and it's taken a long time to get through it. And I'm okay with that. Because again, everybody, showing up here is at different levels. And I'm not going to assume that everybody's ready to drive on a freeway. So that's why I start with a review of Algebra 1 stuff. And then 3.6 is a brand new where Algebra 2 information actually starts to begin. Good? Okay. All right, here's what I already know. I'm going to start up 3.6, but I'm not even going to come close to finishing all the information in 3.6. All the information in 3.6 is not on the test. All the homework stuff is not on your test. The test is very straightforward and simple for 3.6. But you still need to finish the homework so that you can get full credit on the homework. So you can understand. Okay. In order for me to do that nicely, and and you'll, if you've had it before, he's gonna do it again. I'm pushing the test back to the following Tuesday. So Tuesday, the 8th. So homework will be changed. Now, that means on Thursday, this is actually when the review is going to happen. I'm going to give you the review sheet today. And here, this is where we're going to finish up our 3-6. We're going to start it right now, but we're going to finish up 3-6 here. But I'm also going to be doing 8.1 a little bit on Tuesday next week. No. Tuesday. And 8.1 is just like 3.4/3.5. So it's going to reinforce what we've already done. Okay, it's not a bad thing. So 3.6. We've been dealing in chapter 3 with ordered pairs. Every set of ordered pairs, an X and a Y, is called a relation. There's a relation between the X value and the Y value. There's some kind of relation. There's some kind of relation between the X and the Y. Ordered pairs basically is gathering of data. If you get it from this class, you can take a stats class. In stats, you collect data. Usually you're measuring one thing versus another thing, like over the course of so many years, that would be your X values. What is the cost of living in a certain area? Or what is the population? That's your Y value. What is the cost of living? That's your Y value. The years is your X, but then what is the cost and how that's changing? That's your Y value. Okay. The population of male students, that's your X values, and the total number of graduates of male students, that's your Y values. You're collecting data and you're analyzing data. Ordered pairs is a relation. All sets of ordered pairs are relations. Certain sets of ordered pairs are considered to be functions. So every set of ordered pairs is considered a relation. Special sets of ordered pairs are considered to be functions. Now here's where functions come in. Functions are going to be the bread and butter of all algebra. Okay. I don't want to get too far ahead of myself, but I'm just going to do this. We just got done with this problem. And it was, you had x squared minus 4x plus 3, and you're supposed to find the value for x equals 2, then x equals -2. Find the value. What if you had to evaluate that expression for x equals 5, x equals 8, x equals 9, x equals -4? Well, you would have to basically do this every single time. For x equals 2, here we go. Let x equal 2 and then plug it. Let's start over. X equals -, plug it. Let x equal 5, plug it. And then start over. So here's where in mathematics this evolved. We have expressions that represent something versus something else. So they became an equation. Y equals the value, some answer equal that expression. So when you plug in the x value, you always got some answer y that came out. Okay, so you first started, here's an expression. Let's change x up a whole bunch, but how do you represent those answers? Well, you have, here's your x's and you got an answer. But what does that mean? Well, every time you plug in these numbers, this is the answer that comes out. They are ordered pairs. 2 went with, what was that? -1, 2 went with -1. And then -2 went with 15. Ordered pairs. Because when we plug in x, we get a y value that comes out. Okay? So it evolved. Mathematician by the name of Leonard Euler in, I believe it was the late 1700s, developed a nice simple notation. Instead of y equals this expression and then individually setting up, okay, let x equal, let x equal, let x equal. If I want to evaluate, he changed the notation for y and he replaced, so we have y equals x squared minus 4x plus 3. And he replaced y with this function notation, f of x. It's called function notation. So the bottom line is the y in this equation is now just f of x equals x squared minus 4x plus 3. Make sure you get this. Y is the same as f of x. They're interchangeable. The equation of a line. Y equals 2x minus 4. I can write the equation from slope-intercept form using function notation. If I want function notation, all I do is switch y with f of x. Replace y with f of x equals 2x plus 4. Minus 1. That's what function notation means, f of x. Now, I'm saying f of x. F of x, not f times x. F is not a variable. F is the name of the function. It's Freddy the function. Because here's the deal. You might have more than one equation. Usually we plot more than one kind of equation. You got to graph more than one thing. So you might have an f of x equal to 3x squared plus 2x minus 5. You might have g of x. This is Vito. Yeah, Fred, you got Vito. G of x equals negative x squared plus 5x minus 4. You might have h of x equals 2x minus 7. Hugo of x. The h, the g, and the f are just the names of those functions. Instead of having y equals, well, which y am I graphing? Which y is that one? Which y is this one? Which y is that? If they're all called y's, how do you know which y is it? So we label it with different names for these individual functions. F of x, g of x, h of x, in calculus, you can measure the path of a flying object that flies through the air that acts with gravity. The two forces acting upon that is the force that I threw it with and the force of gravity bringing it back down. So the height of an object in calculus with respect to time is the position function. Green just doesn't show up. Is S of t, the position at any time t, is equal to -1/2 gt squared plus v naught times t plus s naught. I'm not saying s naught, I'm saying s naught. Now, I'm speaking some math. -1/2 times the gravitational force time squared the initial velocity that you threw the object with or launched with times time plus the initial position from which it was launched. So if I'm launching it and I throw it from here, I'm launching it from about 5 feet. So that initial number right here would be about 5 feet. With my arm, I'm lucky to throw this about 2 feet per second. Because my arm is just dead. Gravity, that's a constant. The attraction, acceleration due to gravity, if you're in feet, is -32 feet per second squared. If you're measuring in meters, it's -9.8 meters per second squared. Just depends upon if you go on metric or you go on with traditional units. But the velocity at any time of that flying object is equal to -gt plus v naught t. That's the velocity of that object at any time. And the acceleration of that object at any time is just -g. Because that would be the only force acting upon it would be gravity. That's the acceleration of the object. 3 different names all happening to one object as it flies through the air. Okay, that's the difference between the math that we're doing right now, algebra. The math that you do at this level is like you take a snapshot and you're doing math and the picture's frozen. Nothing's moving. It's called a static system. Static means frozen. In calculus, we want to do math while the system's dynamic, while it's in motion. Calculate the values as everything is still moving. Okay? And the only way you can do that is you know your algebra really well. I don't expect you to care about this stuff. What I need you to know is function notation. It's just a way of writing equations when you need multiple equations. We call it this. We call it basically different notation to distinguish one equation from another. It is also a lot nicer to plug in a whole bunch of numbers. So back to this thing, and we had to plug in all those numbers that I have here. I have f of x instead. Read. We have f of x equal to x squared minus 4x plus 3. Instead of going let x equal 2, let x equal -2, let x, we would just say f of 2. Find f of 2. And again, it's not multiplication, it's not f times 2. It's plug 2 into the f function. Substitute 2 in for x. In other words, if I replace this x right here, if I replace it with a 2, then I replace all the x's with a 2, just the x's. So f of 2 is now x squared becomes 2 squared minus 4 times 2 plus a 3. And I don't have to go through the whole let x equal and then figure it out. So f of 2 equals 2 squared 4 minus 8 plus 3. So f of 2 is -4 plus 3, -1. F of 2 is -1. That gives me an ordered pair. What did I plug in for x? I plugged 2 in for x, and what answer came out? -1 would be my y value. Because what that f of x replaced, remember, the f of x replaced the y. These are the y values. The answer that comes out is your y value. What goes in is your x value. And then when you're ready to do f of -2, we just go, all right, f of -2. So you plug, instead of 2 in there, replace that x with a -2. Parentheses. X squared becomes parentheses -2 x squared minus 4 times x minus 4 times -2, and then a plus 3. So f of -2 is equal to +4 plus 8 plus 3. So f of -2 is equal to 12 plus 3, 15. So when we plug -2 in for the x, the y that came out is 15. We ignore a pair. That's how you evaluate functions. Whatever you're told to plug in for this x, it replaces any x's that are on the other side of the expression, the other side of the equation. That's how you use functions. So let's talk about what we're doing. What we plug into a function. So you have two things. You have an independent variable and a dependent variable. Obviously, if you have independent, you have dependent. An independent and you have a dependent. Independent doesn't matter what it is. You know, it can be anything it wants to be because it's independent. The dependent variable, think about it. The dependent variable is going to depend on whatever the independent variable was. One is going to have to depend on the other. The independent variable could be anything you want to do. The dependent one, well, plug that independent one in, and then the dependent one is what you get. So the independent variable, the independent one, is it the x or the y? It's the x. It's what you get to plug in, because it doesn't matter what you plug in. I can just randomly pick numbers. It doesn't matter what I pick. What comes out, well, when I choose an x to plug in, what comes out depends upon what I plugged in. I plug in the x's, out comes the y. So the dependent is the y, the independent is the x. They have special names: domain and range. Domain is the x values. Domain is what you plug into functions. Range is what comes out, the range of what you have, that comes out. Now, it gets very, let's say, nerdy right now. And I'm not going to go too nerdy, and on your test, I keep it real simple. Every set of ordered pairs is a relation. Ordered pairs have domain and range. The x coordinate is always the domain. The x coordinate, whether it's a relation or a function, no matter what, the x's are the domain. So a relation is any set of ordered pairs. The x coordinate is the domain. The y coordinate is the range of the relation. Or if it's a special case, it's the range of the function. Now we'll talk about how we get a function in just a minute or so. This is what you're going to see on your test. I'm going to give you a set of ordered pairs, just like in this homework question. It says, find the domain and the range of the given relation. Find the domain and then find the range. Use a comma to separate your answers as needed. The domain is the x's, the range is the y's. So on the homework, this we pull it up as a homework question itself. So my domain, I have a 5, a -3 is an x, a -8, and a 6. Those are all the x's from those ordered pairs. On your test, and I'll show you, the directions are going to say, when you write down the domain, just list the numbers in increasing order from smallest to biggest. So here's the individual ones, but if you put them in that order, it's not going to be right. From smallest number to biggest number. Also, no repeats. No repeats. So if there's a number that repeats itself, you only write it once. So for the domain, out of these 4 numbers, what's the smallest one? The -8. So I would type in the -8 first. What's the next biggest one? The negative. Oh, wait. I'm going to check that off so I know I can compare it. -8. Then -3 is the next biggest. What's the next biggest? Huh? The 5 and then the 6. So -8, comma, -3, comma, 5, comma, 6. Enter. Okay. And then the range. So for the range, my potential range right now is comprised of a 9. I'm just going to list a 9, a -5, a 6, and a -8. So the first thing I'm doing is just writing them down. And then when I'm actually going to write them in, I want to make sure I put them in the right order. What's the smallest one? The -8. The next biggest, -5, and then 6, and then 9. So that's how you do the domain and the range for the homework. Okay. Here's what it looks like on your test. And your test directions. State the domain and range of each relation And then indicate which relations are also functions by circling the yes or the no at the bottom of the box. And I haven't talked about how you figure that out, so I'll talk about that today or today as well. But look at all those numbers, and you got fractions, all the mess of things. Want to get it? I hope you do. Then don't just go here to put the right answer. My potential domain. I'm just going to copy down all the x's. -4, 9, and then I got a 4, and then I have square root 5, and then I got another -9. I have -9, positive 9, negative, and then I have -8/3. Okay. Make sure you have all of them. 1, 2, 3, 4, 5, 6 ordered pairs, and I wrote down 1, 2, 3, 4, 5, 6 x values. The directions. You must list the elements in ascending order, so smallest to biggest. No decimals. And no repeats. So here's the thing about domain range. The domain is like a bag of numbers that you get to plug into a function. Now, in that bag of numbers is just going to be represented by what you would get to use. Here, you have -4, +4, 9, -9. Everything's fine. They have an individual x value, no repeats. But when you look at the y values, right here, you have a 5 and a 5. You don't list the 5 twice. You're not going to list it twice because the range is only going to have one 5 value. No repeats. The range is just telling you what y's could possibly come out. A 5 would come out. You don't need to list that there are 2 5s that come out. So that's why you make a list of what might work or what they're consisting of, and then you narrow it down. So look what I did. I listed them out. Now, I got to put them in the right order. So let's just look at the negative. Okay, that's simple. That's simple. And then this, where does this go? Well, 3 goes into 8 2 times with 2 left over, 2 2/3. So this is like -2 2/3. So out of -9, -4, and -8/3, which one of those is the smallest? -9. If you're going to make a number line, which one would be furthest from 0? You got -1, 2, 3, 4, -5, -6, -7, -8, -9. -9 would be here. Then you got your -4, and then -2 2/3 is right about here. So the smallest one is the furthest to the left. -9. Check it out. Then -4. And then again, stay with the improper fraction. I only wrote it like this so I would know where it would fit. The last 3, 9, 4, square root 5. So 1, 2, 3, 4, there's 4, 5, 6, 7, 8, there's 9. You have a calculator. You can just press square root 5 on a calculator. It's approximately, I believe, 2.7. I think, something like that. 2.71 something. That might be too big. But anyway, is it big? Is it between 0 and 4? Is it between 4 and 9, or is it bigger than 9? Yeah, it's 2.7. It's right about here. There's square root 5. So it would go next. Square root 5, no decimal. But I'm just going to figure out, I'm going to look at my calculator, see what the decimal is, so I know where it's going to go in my list. That's all. But when you write it down, no decimals. And then you have your 4 and your 9. That's how you write the domain. And then the range, do the same thing for the watch. Now, last part here. Is it a function, yes or no? Here's how you have special ranges that become functions. In order to be a function, the x coordinate cannot repeat. In other words, for every x, you get one y only. X cannot happen more than once in any ordered pair. You could have 5, 3, you could have -5, 4, you could have 6, 3. The y's can repeat all day long. But if you have a -5, 2, this set of ordered pairs is just a relation, it's not a function, because this ordered pair, this x is -5, you get a 4. This ordered pair, this x is -5, it's a 2. The x repeats itself. And this is why it's not a function. When we plug in -5, the answer is 4. But a little bit later, I plug in -5, we get a 2. Make up your mind. Why is it a 4 here and a 2 there? It can't give me 2 different answers if it's a function for this y value, or sorry, for this x value. Now, y can repeat, that's okay. The x coordinate cannot repeat. For those 6 ordered pairs, all the x's were different. Since all the x's were different, it's a function. If this x was a -4, so you have 2 x's that are the same, not a function. Okay. That's why I know I need to go, I'm just kind of giving you a lay of the land before we actually really get into it on Tuesday. Make sure you finish that first homework, 3, 4, 2, 5. Let me make sure I take roll. I know he didn't get a quiz back, but I do have to ask one more real quick. Is Leilani here? All right. Roll is taken. Have a good weekend. Make sure you finish 3, 4, 2, 5. Oh, review sheet. I wanted to give it to you. My bad. And all over the place. I will meet you at the door. Again, on the back of the review, those are the answers. They're not more problems. You should be able to do 1 through 12 on the review. One through 12. Last set of questions for what we haven't finished talking about. So 1 through 12 is what we're able to do right now. The last set we're going to finish talking about.
Oh, yeah, I got one.